Welcome everybody. I'm PVS Kiran from course branch CSC specialization in artificial intelligence and machine learning. My registration number is 21BA1718 and I'm going to explain you on the topic application of automata theory in economics. I'm studying this subject under the faculty of year Amata S. Before going to the slides, let us know what is actually automata theories. Automata theory is just a simple machine. Uh, which is also derived from the plural form of automaton. It is the study of abstract machines. Abstract machines are those which are also known as automata, and they can make different forms, ranging from simple models to more complex models like push-down automata and Turing machine. Uh, like one of the key goals of this automata theory is to understand computational power of these abstract machines only. In other words, what type of problems and can these machines solve and how efficiently they can solve by themselves. The question is closely related to the field of formal languages, which studies the properties of formal languages and these relationships to automata. In particular, automata are classified based on the formal languages only. For example, a finite state machine can recognize regular languages, while a push-down and a push-down automata can recognize a context-free languages. By studying the properties of different types of automata, we could able to understand this concept very easily. Let us know what is actually abstract machine is. Abstract machine is also known as abstract computer. It is the theoretical model of the computer, hardware or software system used in the automata theory. Abstraction of computing processes is used in both the computer science and the computer engineering disciplines and usually assumes discrete time paradigms. Abstract machines are often used in thought experiments regarding computability or to analyze the complexity of the algorithms. What do you do here? We just construct abstract models of computers and computations. These models process the important features that are common to both hardware and software. These features are essential to many of the special and complex constructs which we encounter while working with these computers. What are models? These models can be constructed by one of the essentials of any scientific discipline. The useful of, if you ask me what is the useful of this discipline, means the usefulness of the discipline is often dependent on the existence of the simple automata or powerful theories and laws are also available. What is automaton? Like we discussed earlier, it's an abstract model of a digital computer. It has mechanism to read input. If you assume like a string containing zeros and ones, it reads the input from 0 to 1 till where it ends. For that, the finite automata contains set of states. The states are nothing but you can Q0, Q1, Q2, Q3. Let us assume Q1 as the starting state and Q3 as the final state, and each state are connected with each other through any through 0 or 1, like you assume. It controls it controls move from state to state to response the external inputs. As we said, no, like if Q1 is like related with the Q2 with 0, Q2 may also related with the Q1 with 1 also. With every automaton, a transition function is associated which gives the next state in terms of the current state. An automata can be represented by the graph also, in which the vertices gives the internal states and the edges transition. The labels on the edges shows what happens in terms of input and output during these transitions. An automata operates in discrete time frame. There are some components of the automata. Input file, storage unit, control unit. In input file, strings contents of input symbols. In storage unit, it consists of unlimited number of cells, each capable of holding a single symbol from any alphabet. Control unit, it can be anyone, like finite number of internal states, like can change states in defined manner. Here you can see like transitions from starting state to end state. There are 4 objects. If you assume cabbage, man, wolf, and goat, or no one bank, and there is a goat. All four have to cross the river. See, the boat is crossing the river. All four need to cross the river so that C, comma G or W, comma G are not left at one place. So that these two are not left at the one place. Man rows the boat and takes one at a time. This is the present state, and this is the final state. Intermediate states. In this, this can be these two are intermediate states. Let us see what are some applications of automata. A variety of properties concerning the models, grammars, and language can be proven. The existence or non-existence of algorithms for processing languages and language sources will be proven. These algorithms from the basis of tools for processing languages, example, parsers, compilers, assemblers, etc., automatically construct language processors, for example, YACC, LEC, etc. Note that the perspective with this similar yet different from the complex class. Additionally, some things will be proven to the non-computable, for example, the enhanced compiler. There are different kinds of automata. These was only one example for computational device, and there are others. We will look at different devices and look at these kinds of questions also. What kind of problems can be given? Type of device solve. What things are impossible for the kind of device? Is one type of device are more powerful than the other? What kind of problems can a given type of device solve? It can solve any kind of problems. Some devices we will see finite automata, Postone automata, Turing machines, time-bounded Turing machines. In, like, if you go through these four deeply, you could able to know what actually these four can play their role. For example, if you see finite automata, we will understand what kind of things a device can with finite memory can do and what it cannot do. Introduce simulation, the ability of a one device to imitate other device. Introduce non-determinism, the ability of the device to make arbitrary choices. And the second one is push-down automata. These devices are related to grammars, which describe the structure of programming and languages and natural language also. Now, one of the most important topic in our session is that Turing machines, and this is also one of the highlight of the course. Turing machine is the general model of the computer capturing anything that which we could ever hope to compute. But there are many things that computer cannot do. Let us see what is actually going. Some highlights of this course in this time-bounded Turing machines. Many problems are possible to solve on a computer in principle, but to take too much time to practice. Traveling salesman. The traveling salesman also is one of that kind of problems. It given a list of cities, find the shortest way to visit them and come back home also. You can see some of the diagrams here. Complex system description using automata based agent model. In this first one is a global complex system, global dynamics and structures. A structure is given, and here also same that kind of thing. How these are related to each other and interacting and entities network. Agent based model for entity. Automata based model for agent behavior. We can go through this and see this environment is how it is related to the behavior of these computers. So it's all about automata based adaptive behavior for economical modeling. Here also some of the figures are given like this is starting, this is the final state. It is like the loop, the self loop is given to itself CC, and CC is somewhat a language or a word. And here also the final state also is closer with himself with a for loop. It is also the complement of the CC. This is also tit for that strategy automata. These two figures also gives you such an idea on these. And finally, thank you for your listening. Thank you so much.